Okay, today we will be talking about Unit 6.2, that means the right triangle trig. In geometry, you have learned about the sine, cosine, and tangent, but in reality, there are 6 trig ratios. The counterpart of sine is cosecant, the counterpart of cosine is secant, and for tangent, we have cotangent ratio. We write sine as sin, cosine as cos, tangent as tan. The same way, uh, you have learned about sine, cosine, and tangent as SOHCAHTOA. That is an acronym so that you can understand how to write the ratios. So, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So, in this SOHCAHTOA, O represents opposite, H represents hypotenuse, and A represents adjacent. At the same time, cosecant, secant, and tangent can be written in the abbreviated way. For example, cosecant is CSC, secant is SEC, and cotangent is written as COT. Also remember, in SOHCAHTOA, the middle term, that means in SO, O, K, A, in TOA, O, they becomes the numerator and the last term becomes the denominator. So how to write cosecant? Cosecant is nothing but the opposite or the reciprocal of sine. Secant is the reciprocal of cosine, and tangent is the reciprocal of the cotangent is the reciprocal of tangent. So keeping that thing in mind, if sine is opposite over hypotenuse, then cosecant will be hypotenuse over opposite, right? It is just the reciprocal. And the same thing will go with the secant and cotangent. So we can write these ratios down. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. So these are the 6 trig ratios. Now, how to understand which is the opposite side and which is the adjacent side? If we have a right triangle, so first thing first, the side length opposite to the 90 degree is called hypotenuse. So always label the triangle. Make an arrow right across the 90 degree to label it as hypotenuse. Now we are left with theta. So theta is the bottom angle. And how to understand the adjacent and the opposite? There are different ways. You can say the hand rule, the finger rule, whatever works for you. So the main idea is if you put your hand on the given angle theta, that will touch the adjacent side and the hypotenuse. And the side length opposite to theta is called the opposite side. So if you label all the sides by using the arrow, it will be really, really helpful. So these are the basic 6 ratios and how to identify opposite, adjacent, and hypotenuse. Now building on that, let's talk about the Pythagorean theorem. So if you remember the Pythagorean theorem from your middle school, Pythagorean theorem talks about the right triangle only, right? So we can use Pythagorean theorem only for the right triangle, and in this case, we are using the right triangle for the trig. So what is the Pythagorean theorem? Pythagorean theorem says that the hypotenuse squared will be the sum of the 2 legs squared. So let's create one right triangle on the coordinate plane and let's label it. So on the x-axis, we can label it as x, and we can label height as y. And the other side length of the triangle is nothing but the hypotenuse. Let's have the angle as theta. So as per the Pythagorean theorem, a squared plus b squared is equal to c squared. So a and b, they are nothing but the legs of the right triangle, and c is the hypotenuse. So let's define x and y. So let x is equal to 2 radical 3 and y be just 2. Now we have two legs of the triangle that are given. I need to calculate the hypotenuse. So what we will do, we will use the Pythagorean theorem. So 2 radical 3 squared plus 2 squared, and that will be equal to the hypotenuse. So I label the hypotenuse as a question mark because that is the unknown. So my answer will be 4. And this is nothing but the hypotenuse. Clear? Now, so what is y in this case? Y is opposite to theta and x is adjacent to theta. So adjacent side of theta. So this is whatever we have discussed right now. Most of them, it is a recap of geometry except the 3 new trig ratios that you learned just now. That is cosecant, secant and cot. Now let's write all the trig ratios. Now we have all the sides and we can write all the ratios down. So sine theta will be 1/2, cos theta, which is adjacent over hypotenuse, will be 2 radical 3 over 4, which is nothing but just a radical 3, and tangent theta is opposite over adjacent, so it will be 2 over 2 radical 3, but I need to rationalize it, so it will be radical 3 over 3. So let's write cosecant. Cosecant is nothing but 1 over sine theta, so reciprocal of sine theta. Secant will be reciprocal of cos theta. And remember, we don't like radical in the denominator, so rationalize it. Same thing with cot theta. Cot theta is the reciprocal of tangent theta. So if a question asks for write all the values of all the trig ratios, this is how you will approach that particular problem. Now, keeping that thing in mind, we need to use the trig identities. Before that, let's go back and discuss about the special right triangles. You have done 45, 45, 90 and 30, 60, 90 triangle in your geometry. So I like to make a table out of it so that I can write all the numbers, all the values correctly. So the rule for 45, 45, 90 is x, x and x radical 2. So for example, if I take x is equal to 1, what will be the side lengths? The side lengths will be 1, 1 and just radical 2. And what is the rule for 30, 60, 90? It is x, x radical 3 and 2x. So you have done how to derive these values. For 45, 45, 90, you can use a square, take a half of it and then derive it. For 30, 60, 90, you can use the equilateral triangle to derive these values. and you have done that in geometry. So if value of x is 1, then for 30, 60, 90 it will be 1, radical 3 and 2. Those will be the values. If I create another right triangle, so let's say we have 45 degree, 45 degree, and then a 90 degree. So I know the side opposite to 90 degree will be hypotenuse, so it will be radical 2. So we are just considering the value of x as 1. So what will be sine? Sine of 45 degree. I can just take the top 45 degree or the bottom one. Let's take the bottom one. Bottom angle is 45 degree. So the sine will be opposite over hypotenuse. The opposite is 1, but I need to rationalize it because we don't like radical in the denominator. Cos 45 will be same as well. So you can see from here that sine and cosine at 45 degree, they are the same. If I have to write the tangent of 45, tangent of 45, again the tangent is nothing but opposite over adjacent, so it will be just 1. But here's the thing, there is another way to figure out what is tangent. Technically, tangent is nothing but, and this is very, very important. So tangent can be written as the ratio of sine over cos. So if you divide sine theta by cos theta, you will get tangent theta. The reason is sine theta is opposite over hypotenuse and cos theta is adjacent over hypotenuse. Let's prove it, if tangent theta is sine theta over cos theta or not. So I want sine theta over cos theta, which is opposite over hypotenuse divided by adjacent over hypotenuse. As you can see, hypotenuse is common. I can cancel it out. What is left? Opposite over adjacent, which is nothing but tangent theta. So this property is very, very helpful. So make sure you write it down in your notebook. The other thing from geometry that you might recall is the cofunctions of complementary angles. Now, what does that imply? If you remember, in geometry, we discussed that sine, the complementary of sine is cos, complementary of cos is sine, and the same thing goes with tangent and cotangent, cosecant and secant. So basically sine and the angle 90 degree minus theta will be cos theta, cos of 90 minus theta will be sine theta, tangent 90 degree minus theta will be cot theta, and along the same line we can say cot 90 minus theta, cot 90 degree minus theta will be tangent theta, and secant 90 minus theta will be cosecant theta. So this is just the recap. Now, let's use some trig Pythagorean. We just did the regular Pythagorean, right? A squared plus b squared is equal to c squared. Let's apply that in the trig. So in the trig identities, the Pythagorean theorem that you need to memorize, and it's very, very important moving forward, is that sine squared theta plus cos squared theta will give you 1. Now there are many extensions that we can derive from this Pythagorean identity. If I divide this whole entire equation by sine square theta, I will get another identity. Let's see. So I know sine square theta divided by sine square theta will be 1. Now what is cos square theta divided by sine square theta? This is nothing but the reciprocal of tangent, and the reciprocal of tangent is what? It is cot theta. So tangent theta is sine theta over cos theta, and if you take the reciprocal of tangent theta, that is a cot theta. So basically cot theta is cos over sine. So from the basic Pythagorean identity, I can derive another identity by dividing by sine square theta, and you will get 1 plus cot squared theta is equal to, now what is 1 over sine square theta? That is a cosecant theta is equal to cosecant squared theta. So this is another one identity. Along the same line, you can derive more identities. So let me write down this identity. So same way we can derive other identity. In this case we did division by sine square theta, right? The another identity can be identified by dividing by cos squared theta. And if you divide by cos squared theta, the identity that you will get will be so the identity that we will get after dividing cos squared theta will be 1 plus tangent square theta is equal to secant square theta. So all these three identities are very, very important, and we can derive even more properties out of it by adding 1 or subtracting 1 from both sides. So let's take a few examples. So let cos theta is equal to 0.25, and the question is asking us to find out what is sine theta and what is tangent theta. Now just with one information, how we can figure it out? We can by using a Pythagorean identity of trig. Pythagorean identity of trig is sine squared theta plus cos squared theta is equal to 1, right? And cos theta is given. So let's substitute the value of cos. Squared is equal to 1, and then you can subtract 0.25 squared both sides. You will get sine squared theta is equal to 0.9375, and then take the radical both sides. So sine theta will give you approximately 0.9682. Now what is tangent theta? Tangent theta is sine theta divided by cos theta. So I will plug both the values and we will get our answer. And our answer is 3.87. Okay, now let's use these identities. So quite often you will get the questions where you need to prove that the right hand side of the equation is equal to the left hand side of the equation by using the trig identities. So let's take one example. So we have this equation, sine theta times cosecant theta is equal to 1. I need to prove it. So first thing, identify which is the right hand side and which is the left hand side of the equation. So let's write it down. So 1 is our left hand side and sine theta times cosecant theta is right hand side. So my intention for this question is to prove that the right hand side is also equal to 1. If you look at this, I can rewrite cosecant theta in terms of sine theta. So sine theta is 1 over sine theta, right? Now I can cancel out sine theta and sine theta and we are done. 1 is equal to 1. Let's take another example. Now we have cosecant theta plus 1 in the bracket and then another bracket cosecant theta minus 1, and they want us to prove that it is equal to cot squared theta. Now if you look at this equation carefully, we can say, first identify right hand side and left hand side. After that, if you look at the right hand side, this is in the format of a plus b, a minus b. And if you remember, a plus b times a minus b is nothing but a squared minus b squared. So I can rewrite it as cosecant squared theta minus 1. And that should be equal to cot squared theta. But do we know what is a cosecant squared theta minus 1? Let's go back to our Pythagorean identity. So identity number 2, 1 plus cot squared theta is equal to cosecant squared theta. We can use that. So let's manipulate that identity. So we know that 1 plus cot squared theta is equal to cosecant squared theta. Now if I subtract 1 from both sides, what will happen? Subtracting 1 from both sides, let me change the color first, will give you cot squared theta is equal to cosecant squared theta minus 1, and this is what we are looking for on the right hand side. So I can replace right hand side with cot squared theta, and that matches with the left hand side. So hence we proved that right hand side is equal to the left hand side, right? Okie dokie. Now let's understand angle of elevation and angle of depression. So elevation is nothing but when your mood is elevated, your chin is always up, right? You are in a happy mood. When you are not in that happy mood, that means when you are depressed, you tend to look down. So the same way, angle of elevation is just like someone is looking up. Right, someone is standing, observer is standing here and they are looking up. Angle of depression on the other hand is just looking down. And when you are looking down, the angle that is formed, that is called angle of depression. Let's take one example based on angle of elevation and angle of depression and using the trig identities. So the question says, find the acute angle. And what do you mean by acute angle? That means less than 90 degree. Between the two paths, so I'm roughly sketching the path, and it is forming a shape of a right triangle. So let's label it. So it's not 3 miles, it should be 6 miles. So the hypotenuse is, or this side length is 6 miles. The top side is 3 miles. This is a right triangle. The angle is 90 and that is a theta. So if that is a theta and the tip right here is labeled as ranger station. Now we want angle theta, right? So if you look at angle theta, do you think the side opposite to theta is given? No. Do you think the side opposite to 90 degrees is given? Yes, that is a hypotenuse, which is 6 miles. And the side just next to theta is given, which is nothing but adjacent, and that is 3 miles. So if I use process of elimination for SOHCAHTOA, adjacent is given, hypotenuse is given. So which trig ratio do you think we should use? Pause the video, think about it. Adjacent is given, hypotenuse is given. So the trig ratio is cos theta. And what is cos theta? Adjacent over hypotenuse. So my final answer will be 1/2 miles. And that is our final answer. And to find the angle, you can take the inverse using the calculator.